Elimination method. We've been working with the elimination method, and the elimination method is getting rid of one of our variables. So here we just want to eliminate an x or eliminate a y so we can easily solve for that variable. So with this first example, we have our 2x plus 3y equals 11, and we have 3x minus 5y equals negative 8. I actually want to change this to be negative 12. It's going to make this problem a lot easier for us to solve. So we want to use the elimination method. Now we want the variables, the coefficients, to be the same for them to eliminate. So we want them to be the same, and we want one to be positive and one to be negative. So if we look at these, we have a 2x and a 3x, and then we have a 3y and a negative 5y. Now the ones I'm going to try to eliminate is the y, because one is positive and one is negative. In order to eliminate the y's, they need to be the same. Well, looking at 3 and 15, I know that 3 and 5, I know that they have a common factor of 15. So I'm going to multiply the first one by 5, because 5 times 3 will give me 15. 5 times 3 will give me 15. But I can't just multiply the 3y, I have to multiply everything. So everything. So we get 5 times 2x is 10x. And 5 times 3y will give me that positive 15y, which is what I'm looking for, so I can eliminate my y's. And then 5 times 11 will give us 55. So I multiplied the top one, and now we're going to multiply the bottom equation. We know that 3 times that negative 5 will give us negative 15. But once again, we have to multiply everything in here. 3 times 3x will give us 9x. 3 times negative 5y will give us negative 15y. And 3 times negative 12 will give us a negative 36. Now we can look at this and we can notice that our y's, they're both 15. One is positive and one is negative. So we can box these out. So we add our x's. We get 19x equals 55 minus 36 will give us 19. So 19x equals 19, so we divide each side by 19, and we get x is equal to 1. So now we found our x value. To find the y value, we select one of these two equations. So if I choose the top one, I'm going to write out my top equation, and I'm going to plug in 1 for x. We do 2 times 1 plus 3y equals 11. I'm going to solve this for y, so 2 times 1 is 2, plus 3y equals 11, subtract 2, 3y equals 9, divide by 3, y is equal to 3. So we have our solution for this first example as the 0.13. So now if we look at the second example here, we have 5x plus 2y equals 66, 4x plus 5y equals 80. Once again, we want to use, they're lined up, our x's are lined up, our y's are lined up, so we want to use the elimination method here. But now if you notice, and neither of them are the same. We have 5x, we have a 4x, we have a 2y, and we have a 5y. So we can choose either the x or the y. Since we did y last time, I'm going to show you that we can do x this time. So we know that we have 4 and 5. Well, they have a common factor of 20, so we know that 5 times 4 will give us 20, so 5 times 4, that'll give us 20x, and then 5 times 2y, that's plus 8y, and then 4 times 66, that will give us 264. And then when we look at the second equation, we're looking to get our 20x. Well, we have 4x. Well, 5, we know that 5 times 4 will give us 20, so 5 times 4x will give us 20x. 5 times 5y will give us 25y. And 5 times 80 will give us 400. Now, when we look at our x's, we have our x's. They're both 20, but they're both positive. And we want one to be negative, so I'm going to go back and I'm going to change this to negative 5. So that will give me negative 20. Then it would change this to minus 25y and this to negative 400. So now when I go to box these two out, I have one positive, one negative. They're both 20, both x's. Box the x's out, add it together. 8y plus negative 25y is negative 17y. And 264 plus negative 400 is negative 136. So now simply divide by negative 17. And y equals 8. A negative divided by a negative is positive. 136 divided by 17 give us 8. So we have our y value. In order to find the x value, we go back and we choose one of the two equations. Doesn't matter which one, I'll choose the top one. I'm going to write my equation out again, just to be sure that I get everything right. So I wrote my equation out. I know that y is 8, so we put the 8 back in for y. So it's 5x plus 2 times the 8, and this all equals 66. So we have 5x, 2 times 8 is 16. 16 equals 66. We subtract 16 from both sides, so 5x equals 50. And then we divide by 5, so x is equal to 10. So now I have my x value. So x is 10, y is 8, so our solution to this system of equations is 10, 8. So if we look at the next example, now we have an application problem. It says Cameron was having a pizza party. He bought 5 pizzas and 3 sodas for $4.75. Alright, so when we look at our equation, well, we notice that there's some important information there. Alright, it says he bought 5 pizzas and 3 sodas, and he spent a total of $45.75. So we know that we're talking about pizzas, so we can let P equal our number of pizzas. And we're talking about sodas, so we can let S equal our number of sodas. We could use X and Y, but P and S just work for pizza and sodas. So when we're talking about Cameron, we have Cameron, and we know that he bought 5 pizzas, so that's going to be 5P. He bought 3 sodas, so that'll be plus 3S for our number of sodas. And he spent a total of $45.75, or $47.75. So it equals our total amount. The next thing we want to do is we can go back and we can look at the next sentence. So we continue reading. It says the following week Nicole had a pizza party. It says she bought 7 pizzas. So let's try this one. So 7 pizzas and 6 sodas, and she spent $70. So now we can go back and we can write our equation for Nicole. So we have Cameron, now we have Nicole. When we go back, it says she bought 7 pizzas. So 7 pizzas will be 7P, plus she bought 6 sodas, so that will be plus 6S, and she spent a total of $70, so that equals 70. So now we have our two equations. We have Cameron, we have Nicole. And it says we want to know the cost of a pizza. So we just want to know the cost of a pizza. We're not concerned about how much a soda costs. So we just want the cost of a pizza. So that means we can get rid of our soda. So we can eliminate the S. So if we look at this, we have a 3S and a 6S. Well, we know that 3 times 2 will give us 6. So if we multiply this entire top equation, Cameron's equation, by 2, that'll give us 10P plus 6S, and that will equal $95.50. $47.75 times 2 is $95.50. So we can look at our S. So they're both S's, they're both 6's, but one's positive and the other one's positive. We need one to be positive and one to be negative. So I'm going to go back and change this to negative 2. So it'll be negative 10P, and then it'll be minus 6S. And it'll be negative $95.50. So now I can box out my S's. They're both S's, they're both 6's, one's positive, one's negative. We can box out our S's, and we can add everything else together. So 7P plus negative 10P will give me negative 3P. 70 plus negative 95.50 will give us negative 25.50. And then we divide by negative 3. And P equals a negative divided by a negative is a positive. 25.50 divided by 3 is 8. $8.50. So our solution, the cost of each pizza is $8.50. So let's take a look at the next example. So now example 4. Kanai needs to practice basketball. Mr. Myers and Mr. Brevner have skills practice on the weekends. Mr. Myers charges $20 plus $20 per hour. Mr. Brevner charges $50 plus $10 per hour. It says write a system of equations representing the total cost of H hours. So in this problem, it already gives us our variable, it's H hours. So we're looking at Mr. Myers. Alright, so we'll start with Mr. Myers. So Mr. Myers, it says he charges $20 plus $20 per hour. Well, to write our equation, we'll start off with y equals. Now it's 20h because that's $20 per hour plus 20 because that is the initial charge. And then we have Mr. Brevner. So Mr. Brevner, he charges $50 plus $10 per hour. So we can say we have y equals, well, we know it's $10 per hour. That's 10h plus he charges an additional $50. So now we have Mr. Brevner's cost. So y equals 10h plus 50. The next step, it says determine the number of hours when the total cost for each person is the same. Well, the key word there, we want when they are the same. So we want when these are equal. So we want Mr. Myers' cost to equal Mr. Brevner's. So what we're going to do is we're going to set these equations equal to each other. Since they're both y equals, we can really, what we're really doing is substituting Mr. Myers, which is 20h plus 20, in for the y value, and Mr. Brevner is 10h plus 50. So now we have our equation. So we have 20h plus 20 for Mr. Myers and 10h plus 50 for Mr. Brevner. To solve this, we have h's on both sides, so we have to get rid of one. So if we do get rid of that 10h, we gotta do whatever we do to one side, we gotta do to both sides. So 20h minus 10h will give me 10h. Bring down my 20 equals 50. So subtract 20 from both sides. So 10h equals 30, and then we divide by 10, and h equals 3. So we know that they will be the same for 3 hours. So the cost will be the same at 3 hours. And if we want to figure out what the cost is, well, if we look at Mr. Myers, we have 20 times 3 plus 20. Well, that's 60 plus 20. So the cost for Mr. Myers would be $80. This is Mr. Myers. And then we have Mr. Brevner. And that is 10 times 3 plus 50. So 30 plus 50, and $80. So if we notice the cost is exactly the same at 3 hours. So that wraps up today's lesson on elimination method and some application problems.